Then about natural material, then I'm going a little bit faster, if not we are going too long. Even about natural material, many people think that natural material per se, they are good for the environment. What natural means, sometimes it's not that clear. I can tell you asbestos, asbestos or amianto is a natural material, okay? It's one of the most cancerogenic material on the earth. It's very cheap, very easy to be taken. Can we say that this is environmentally friendly? No, again, it's not that every natural material or what is natural, it is there. So the point is, how many are the person that knows what is environmentally sustainable or not on one side? And on our side, how many are the designer that knows how to design a product that will environmental impact if we still sell those products? And how many are even the teacher are able to teach what is a environmentally or socio-ethically sustainable product? Said this, I want to show you, as I told you, how it went during the course of the year in terms of the potential of design for sustainability. So we move, especially this is more related to industrialized context. For example, a colleague in Brazil would say something slightly different. In fact, he used this slice of mine, but he changed a little bit of, in copyleft ethos, a little bit the position and the year of the different items. So we move from low impact material selection that started in 1970, so research has been making into that. In 1990, the attention of research and then partly of education moved on to product design or eco-design of product. Then more recently on eco-efficient, environmentally and economically efficient product service system, and more recently on design for social equity and cohesion. So in this sense, widening the artifact to be designed. Okay? There are a few words about this. Since the 70s, so the attention was at the beginning on which were the toxic materials, so they were phased out, and so there were rules. Still, again, we are searching about this and material phased out. What are the natural material, but with all the ambiguity that I told you, which are the recyclable material, we start to understood, but even here there will be something to discuss. I take it short. The issue of renewability, so renewable resources, either it's a polymer that is coming from corn, or is energy source, is coming from sun, better than oil, and so on, and biodegradable material, so that can be biodegraded within the environment. So attention has been moved into that, even though with some critical points. So for example, we had a pen which has a biodegradable material that is not good. It could be good if you use it for a sack for compostable waste, okay? So that is fine. You take the sack and you put it into compost, that biodegrades, it's good. You use a vase for flour that is made of biodegradable material, you put a vase into the ground, it biodegrades, it's good, but then it's a very good solution. So it's not that biodegradable is not good, but it cannot be used for everything. You have to think to which product and so on. Then at the beginning of the 19th, the attention moved on design of product, and we start to speak about life cycle design of product. So it is used to say eco-design, but let's say it's more scientific, or it's better wording to say life cycle design, because it tells something that in fact we have moved from simply designing a product to designing the life cycle stages of the product. This was an understanding of those here. So we have to design to reduce the impact in the pre-production when we produce the material or the energy, in production when we transfer the material into component, in the use when we consume energy for this computer, for example, or when we have different services, in distribution when we transport and we have packaging, and in the disposal phase when we have different processes so that it can be then filled, but we can recycle, we can reuse component, and so on. So the point is that the product has to be considered in relation to all the life cycle phases and all the processes, and what are the input and output of all those processes, because those input and output create the environmental impact that we saw before, global warming, ozone layer depletion, and so on. But another key understanding of those here was the so-called functional unit. So we cannot just think about the life cycle of a product. The carbon seat has a very low impact, but even at the function, to be seated for a given given year in this classroom. So for a given year in this classroom, this is the function or the functional unit. I need just one of that chair. A cardboard chair, I need 1,000. So I have to compare 1,000 chair with one of the other chair. So in that case, it came out that it's better to have that instead of the other, or it depends. But the functional thinking, functional form has been debated in the history of design in different way and blah blah. When it comes into the debate, the sustainability issue, function get this new concept into it. It is important to design, to evaluate and to design in relation to the functional unit and to think in relation to that. And of course, with the objective to minimize the environmental impact over all the life cycle phases, not just one phase, not just I reduce the material, I reduce the disposal. No, I have to consider that I reduce in overall the life cycle phases. If I reduce the material, but then it's less isolating that fridge, then it's consuming more energy to keep it cool, the food there in the fridge. So you have to make a balance of these, what is the best, and to think in terms of the functional unit. And so even in those years, different strategies came out, and we will see some of those in the next lecture. So design for material and energy minimization, the selection, design for selecting non-toxic resources, material and energy, design for renewable and conservative material and energy, design for material recycling, composting and energy recovery, design for long-lasting product. We understood how important is this and how controversial it is in our contemporary society in industrialized context and so on. And in those years, or at the end of the 90s, some method and tools were developed by the design research to support the designer. And there is one fundamental tool which is called life cycle assessment, which is a method that is standardized ISO 1440 that permits you to make the environmental impact assessment of a given product during the life cycle, considering the functional unit. So you can say to this how much global warming it determines, how much acidification, and so on and so on. Okay? And you can compare this to another product or an existing product to the concept that you have developed or the product that you have developed. Okay? For example, this is what we are doing in the course of the third year of the bachelor. With my student, we are using life cycle assessment and other tools. And these other tools that have been developed are tools that not only assess but help the designer to orientate the ideation and the creation of the concept or the concept detail towards sustainable solution. There are idea generation tables, there are other tools available. Here I put an example. This is an open software that we have freely available on the Lens platform, and that is for product design. Life cycle assessment we don't have. What we use is has a copyright. We bought it from a company in the Netherlands. It's called CimaPro. But this is to let you know that actually the knowledge on how to design product with a low environmental impact and the tools to design it and to assess it, they exist. This is the key point. So it's a good news. Okay? So we know how to do that. And we know how to assess it. It is there. The knowledge is there. If you want to know more, this is not true. Maybe there are even other books, but this is a book that I wrote. It has been translated in some languages. Okay, someone want to know more. But since the end of the 90s, some attention moved into the design of eco-efficient product service system, something that we will study during the course of this course. Okay, so here just to mention a few things. And in those years, in fact, some attention were given, not just by designer, even other scientists, even from the economic sector, to some cases like Xerox. Xerox was really one of the first one, because Xerox decided not to sell the copy machine. They were not selling the copy machine. They say, oh, Politecnico di Milano, I'm going to give you the copy machine there. You pay per page. Okay, the copy machine remain in my ownership, and if you want, I can have some operator of mine taking care about making the copy and delivering the copy around the offices, so they can offer a complete full service around it. But the key point is that actually they were offering this product, retaining the ownership and collecting it back and taking care about maintenance, repair, up to their own cost. They were paid per copy made. Okay? In this sense, what happened is that it was understood. They did it because they thought that it was a good business, because in a very saturated market of copy machine they had a different offer. Okay, so they offer something that makes the company not to think about repairing this and the other, making copies. So it was good for many companies, and they had some good success about that. But then we understood that this was really very interesting in environmental terms, because since they were paid by copy made, they were interested, we were saying before, what? To have since it was in their ownership, to have a copy machine that lasts as long as possible. If not, they have to rebuild a new one. They have the cost of putting this to landfill and so on. Okay? To make the material to be easily recyclable at the end, because they have to collect it back there. Or if I can recycle, I don't have to buy new material, I don't have to landfill this. I save cost. Okay? So for an economic reason, they were then interested in designing copy machines that were with a low environmental impact, with life cycle design criteria, what we saw before. Okay?